Alright, welcome again in another tutorial of the topic differentiations. So in this tutorial we're going to see some dynamic applications of differentiation application. So mpaka sasa tunajua kwamba velocity ni change of displacement over time. Tushaona kwamba v is just ds dt. Tushaona kwa nyuma, okay? We're going to talk about this again. Lakini pia tushaona kwa hiyo s ni displacement. S ni displacement, alafu v ni velocity. So tushaona pia acceleration now is just equal to dv dt. So a ni acceleration, okay? Tushaona huko nyuma. So acceleration, tushasoma higher derivatives can also be expressed as hivi a sasa na d dt, so badala ya v tunasema ds dt. So this is just going to be equal to the second derivative now of displacement with respect to time. Because this is another way of expressing a. Lakini pia we know that v, velocity, is a function of s. Okay, physics yako hapo. Zile equation tatu. So I mean a can also be equal to dv ds times ds dt. Okay, like this. ds na ds na kufa, we have seen kama chain rule flag. So a can also be v dv ds, okay? Kwa sababu ds dt si ni v. Okay, kwa hiyo ds dt ni v hapa, you see? So nimeweka v and then dv ds hapa. So a can be this one or this one. So we have seen that, so we have this one. We have v is equal to ds dt. Namna nyingine ya kuandika hii ni v is equal to s kadoti. Okay, a is equal to dv dt. Namna nyingine ya kuandika hii ni a is equal to v kadoti. Okay, and tunajua kwamba a sasa na d second derivative, okay? Kwa namna nyingine ya kuandika hii ni hivi, okay? So you can apply differentiation when kutafuta acceleration na velocity na displacement. So let us see an example, okay? Let's just solve an example from hicho tulichojifunza. So I call this example 1. So example 1, it says the displacement x at time t of a moving particle is given by x is equal to a sine 2t plus b cos 2t, where a and b are constants. So if v is speed in, at time t, prove that v is equal to 2 the square root of a squared plus b squared minus x squared. So we just have to prove this, okay? So that's the question. Let's now solve it, okay? So we have x is equal to a sine 2t plus b cos 2t. So if you square both sides like this, x squared is going to be a sine 2t plus b cos 2t squared. So this one is just going to be x squared is equal to a squared sine squared 2t plus 2ab sine 2t cos 2t plus b squared cos squared 2t. So this one is x squared, okay? So, but I know that v is equal to dx dt. So I just have to differentiate this one with respect to t. So I'm gonna get like differentiate all of this guy with respect to t. So I mean my v now is just gonna be equal to a. So we are gonna differentiate sine 2t. Okay, a is constant, so you just unaitoa, and b I'm gonna differentiate cos 2t. So if I differentiate sine 2t, I get 2 cos 2t, and if I differentiate cos 2t, I get negative 2 sine 2t. So my v is just going to be equal to, so here I'm going to have a 2 cos 2t minus b, okay, 2 sine 2t. Okay, that's what I'm going to have here. So this is my v now. So my v is just going to be equal to 2a cos 2t minus 2b sine 2t, okay? So my v squared, if I square both sides, it means I square this one and this one. So I'm going to find that v squared is just equal to 4a squared cos squared 2t minus 8ab cos 2t sine 2t plus 4b squared sine squared 2t. Okay, nikisquare hii ndo napata hii. So naweza nikatoa nje 4. I'm going to remain is a squared cos squared 2t minus 2ab cos 2t sine 2t plus, here I'm going to remain is b squared sine squared 2t. So I can divide by 4 on this side and on this side. So my v squared now over 4 is just going to be equal to a squared cos squared 2t minus 2ab cos 2t sine 2t plus b squared sine squared 2t. So remember now, remember x squared tuli expand zile, tulipata ni a squared sine squared 2t plus 2ab sine 2t cos 2t plus b squared cos squared 2t. Na muda si mrefu tumepata tena v squared over 4 ni sawasawa na a squared cos squared 2t minus 2ab cos 2t sine 2t plus b squared sine squared 2t. So now I'm going to add these two equations. So I'm going to have x squared plus v squared over 4 is just going to be equal to, so huyu na huyu nikijumlisha, a squared is common, so napata a squared, ndani nakuwa na sine squared 2t plus cos squared 2t. Huyu na huyu wanafanana kila kitu, afu mmoja ni plus, mwingine ni minus, kwa nikijumlisha inakuwa 0. Lakini huku I have b squared is common, so remain is cos squared 2t plus sine squared 2t. So cos squared plus sine squared is 1, okay? So anabakiza tu na x squared plus v squared over 4 is equal to a squared plus b squared. So now, I mean, this x squared naweza nikaileta upande wa hii x squared naweza nikaileta upande wa huku. So nitabaki na v squared over 4 is equal to a squared plus b squared minus x squared. So nitakuwa na v squared is equal to 4. So we have a squared plus b squared minus x squared. So I'm gonna do like this, okay? So square root ya v squared ni v, square root ya 4 ni 2. Lakini square root ya huyu jamaa mwingine just is okay. Just iache hivyo. So hence proved. Tumeshamaliza ile example, okay? So these are among the examples of application of differentiation, some application. So let's see another example now. To partial. Call this example 2. Okay? Call this example 2. It says if the velocity of a body varies as the square of the distance traveled. Show that the acceleration of the bodies varies as the cube of the distance. So solution, okay? So this one is velocity v, okay? So velocity ni v, distance ni tutumie nini x, okay? Acceleration ni nini a. Kwa hiyo v varies as x squared, okay? So varies as the square of the distance traveled, okay? X squared, like this one. So we're required to show that acceleration of the body varies as the cube. So required to prove a is directly proportional to cube of the distance. So kutoka hapa tufike hapa, okay? So from here now, I know this is just gonna be kx squared, okay? Where k is constant. But remember now, tulisema a is equal to v dv dx, okay? Remember this one? Nataka kuintroduce pale mwanzoni. Niliweka s lakini badala x. So kama v ni kx squared, dv dx itakuwa ni sawa tu na d dx ya kx squared. So I mean dv dx now itakuwa k naitoa nje na baki na x squared. So nikidifferentiate x squared with respect to x napata 2x, okay? So it's just gonna be k2x. It's just like 2kx, okay? So I get this one. This is dv dx. So a now is equal to v dv dx. So a acceleration is equal to v. V ni kx squared times dv dx ndio hapa tumepata 2kx. So k na k nazidisha na 2, so its acceleration is just going to be equal to 2k squared, okay, times x cube. So acceleration nimekuja kupata ni sasa na 2k squared x cube. So a square of a constant is constant, mbili na yenyewe ni constant. So here 2k squared is equal to c, which is constant, okay? Is equal to c, which is constant. So my a now is equal to cx cubic. C is constant. So a is directly proportional to the cube of displacement. So those were some of the applications of differentiation. We shall see more applications in the next tutorial. Let me say, see you in the next tutorial.